Hello and welcome to this continuation of our discussions on loans. The point of this video is to build on what we did last time with amortization tables. So if you remember, we talked about how to build an amortization table and to see the life of a loan. But for all of those problems, I gave you all of the information you needed. I gave you the payment amount, for example. So one of the goals of this video is to talk about how you can calculate a payment given a loan amount. And then the backwards question, if I give you a payment, I could ask you how big the loan is. So asking you questions like, suppose you've budgeted $500 per month for this loan, how big of a loan could you take out? Things like that. And then lastly, talking about how to compute remaining balances at any given time. Okay, so let's just jump right into it. Here is the loan formula. So little r and little t and little n mean the same thing they always mean. Little r is the APR in decimal. T is the time in years. It's the life of the loan in years. And n is the number of times per year things are done. So n is the number of times that payments are made in this context. Capital R is the payment amount, and capital P is the amount you borrow. So with this formula, I should issue the same warning that I issue with all formulas that we talk about. Each formula is only designed to answer certain kinds of questions. Okay, so each formula only corresponds to certain situations. So this just is a loan formula. This formula models loans that don't use simple interest. Okay, there's compounding here, so there's no simple interest involved. It's not a simple interest setup. Okay, so if you're asked a question about the future value of an annuity, or you're asked a question about APY, or things like this formula won't help you. This formula is only built to answer certain kinds of questions. So speaking of certain kinds of questions, here's one. So Joan takes out a 30-year mortgage of 175 grand, and the APR is 5.2%. She's going to pay off the loan with monthly payments. So what is that payment is the question. And by the way, if you're not comfortable with the term mortgage, that for our purposes simply means a house loan. So she's taking out a 30-year loan to pay for a house. So let's figure out what her payment is. Well, this is a loan setup where the interest isn't simple. Okay, the payment structure is much more complicated than simple interest. So we're going to use the formula we just saw on the previous slide. So all you have to do is at the beginning is just plug the numbers in. So P stands for the loan amount. Capital R we don't know. That's what we need to find. And the other letters mean what they always mean. So here are all those numbers plugged in. So what you should do, like always, is just compute this number, this sort of gross looking fraction, figure out what this number is, and divide it over. So when you're figuring out what this number is, just like with the annuity formula, you don't have to do it all at once on your calculator. So you can do things like ask your calculator what 12 times 30 is first, and fill that in right here. You can do things like ask what 0.05 divided by 12 is, and plug it in there. So if you're not comfortable with plugging all this in at once, if you're worried about making a mistake, just take it slow and compute as many steps as you want to. So for example, here I plugged in some of the numbers. I asked the calculator what 12 times 30 was. I asked what 0.05 divided by 12 was, etc. So let me now just skip some steps. Here's the number I got, 182.11266. So that's what that fraction reduced to. And then when I divide that over, I get $960.94. Okay, so there's the answer. So before we move on, let me just remind you that just like with the annuity formula, if you're going to do these computations step by step, you should not round very much. You should keep 7 or 8 decimal places. Okay, so if you round a lot at the beginning of the problem, your final answer will be very far from the correct answer. So when you're doing your homework, the computer has wiggle room. So you can round a little bit, but the computer is only so forgiving. Okay, so keep 7 or 8 decimal places as you go, and your answer won't be too far off. You can still get it correct in the homework. So we've learned that if she takes out a loan of 175 grand with the other parameters as they are, her payment is $961 or so. Okay, so here's a natural follow-up question to ask. We've computed her minimum monthly payment. So assuming she always makes that payment, how much interest does she pay? And so just so it's clear here what I mean, assuming she always makes that payment, she could pay more than that if she wanted to. The result would be that she pays the loan off early, and depending on the loan, she might have to pay a fee for paying the loan off early. Okay, some banks do that. So if you plan on paying a loan off early, you should check if they're going to charge you for doing that. But in any case, that's all I mean. We're just going to assume she makes the minimum payment here. She's not going to pay any more than that each month. So how much interest does she pay? Well, to figure this out, you simply just need to figure out how much she pays in total, and whatever is above and beyond 175 grand is the interest. So here's what she pays in total. $961 per month for 30 years. So the total amount that she's going to pay to the bank over the life of the loan is about $346,000. Okay, that's a lot of money. So she of course pays the 175 grand back and then some on top of that. So to figure out the interest amount, just take the total amount that she pays, take off the principal, and what's left over is the interest. So she pays about 171 grand in interest. Okay, so she's almost bought herself a second house, right, with this interest. And so house loans are like this. House loans in general are big and the time period is long. That's why the interest is so high. So on car loans or on student loans where you pay it back in under 10 years, things like this, you won't see interest this high. This interest is almost exactly what the principal was. Okay, that's high. So like for my car loan, it's nothing like that. But the interest I pay is like, I don't know, 1% of the principal. Okay, it's not this big. But in any case, it's not unusual to see numbers this big when you start with a big loan and you have it for a long time. 30 years is a very long time. Okay, here's the final kind of question I want to consider. So it's the same parameters. How much does she owe the bank after 15 years is the question. So what is the remaining balance after 15 years? So to answer this question, you already, in some sense, have the tools to answer this question. You know how to build an amortization table. And the amortization tells you at every single row how much you still owe. So if you have a ton of time on your hands, you could build the amortization chart for this loan and then just look 15 years into it and see what the remaining balance is. Okay, but this is not practical, right? You wouldn't want to do this. 30 years with monthly payments means she's going to have 360 rows in her table. So if you want to go halfway into that table, you're talking about building 180 rows. Okay, this would take you hours. So you don't want to do that. One thing you could do is use the remaining balance formula. So here's a formula that will tell you how much you owe after a certain number of payments. So capital B here stands for the remaining balance, which is synonymous with how much you still owe. All the other letters mean the same thing, except notice there's a new letter here, X. X represents the number of payments you've made. So 15 years into this loan, she's made 180 payments. That's what you would substitute in for X. If you cared about the remaining balance after 1 year, then she's made 12 payments, and 12 is what you would substitute in for X, etc. So this formula looks almost exactly like the loan formula itself, but we've introduced an extra term here, this X. And X minus NT is all in the exponent now. Okay, so how much money does she still owe after 15 years? Well, we're going to use the formula, but let's first think about what the answer might be. So she borrowed 175 grand. and 15 years is halfway into the loan. Therefore, it stands to reason that she would owe half of 175 grand. So that's a guess we could make. Okay, we're halfway into the loan, so it seems reasonable that she would have paid half of the loan off. So that's our guess, or that's at least my guess. Maybe you have a different guess. So let's see if the formula confirms this or not. So here's the remaining balance formula. Again, all the letters mean the same thing, except X now is how many payments you've made 15 years into it. So let me plug the numbers in. Okay, so I just did it here. One thing I want to point out though, T, time, always stands for the life of the loan. So a common mistake people make is to put in 15 for T, because the question is asking about 15 years. Okay, but T is still 30. T is the life of the loan. So N times T is 360, just like it was before. X is what depends on this 15 years. So 15 years into the loan, she's made 180 payments. So that goes right here. So the exponent up here is 180 minus 360, which is negative 180. So that's what goes in the exponent now. Okay, but just like before, you can just take this computation one step at a time, and what you will end up with is almost 120 grand. Okay, so that's way more than half of 175 grand. Okay, so our guess was off by what, like 35 grand? Okay, so it's you're nowhere close to being halfway done with paying off the principal. Okay. So these are the kinds of questions you will answer in your homework. So I want to show you two things. The first thing I want to show you, and you don't need to be able to do this, I took this loan and I graphed the remaining balance over time. So the horizontal axis here represents time. The vertical axis represents how much you still owe. The vertical axis represents remaining balance. So your remaining balance does this over time. It curves down. So what does that mean? So if you focus your attention up here, this is early in the loan. The time hasn't gone very far. Notice that this curve doesn't fall very fast. Okay? So what you still owe on your loan does not go down very fast. Why is that? Because at the beginning of your loan, more of your payment is going towards interest. When more of your payment is going towards interest, that means less of your payment is going to actually paying down your loan. So the amount that you owe on the loan is going down, but it's going down at a snail's pace. But as time moves forward, more and more of your payments are going towards the principal itself, so the rate of fall actually accelerates. So down here at the end of the time period, the curve is actually falling pretty fast. That's because towards the end of the loan, you don't owe that much anymore, so the amount of interest that you're paying each payment is small. So more and more money is going to paying down the principal. Okay, so that's how you can see why the remaining balance does what it does. And so let's actually get a handle on the halfway point. So this curve represents remaining balance. This curve just represents the number 87,500, which you'll remember is half of 175,000. So I'm just going to ask the computer where they hit each other. And so if you look down here, the X value is 244. That means that it's going to take 244 payments before you cut the amount you owe in half. So let's just figure out how many years that is. So 244 divided by... Okay, so that's almost 2/3 into the loan. All right, so it's a 30-year loan. That means it's going to take about 20 years until you've cut the principal in half. Okay? So it takes longer than you think. You might think you'll cut it in half in 15 years, but it actually takes 5 more years after that to actually cut the original principal in half. Okay, but in any case, hopefully this clears up why that's true. The decline of the principal is slow at the beginning and accelerates towards the end. Okay, one other thing I want to show you. you will be able to use this calculator on some of your exam. Not all of it, but on some of it. And you'll be able to use it on some of your homework. So let me show you how this works. We used this in class the other day briefly. This is a mortgage calculator is its title, but again, mortgage just means a house loan. The computer does not know whether the numbers you're giving it are for a house or not. So the computer, where is the formula? The computer just has this formula programmed into it. Okay, so it's just doing what we just did, but it's doing it for you. So you tell the computer, oh, that was the loan we just did. Okay, Joan's loan here was 175 grand. So 175 grand for 30 years at 5.2%, and it tells you what the payment is. We already know it. It's $960.94. Okay, so this calculator is limited in scope because it assumes monthly payments. So you'll notice there's no way to change that. It's in months. So if you have a question about quarterly payments or even daily payments or payments once every 2 weeks, whatever, this calculator won't help you anymore. So you have to have monthly payments. Also, this calculator takes the loan amount and gives you a payment amount. The calculator does not do the backwards question. You can't just hand it a payment amount and ask it how big of a loan you can afford. Okay, so this calculator is limited that way. But the reason I like it is because it does a lot more than just calculate the payment, the monthly payment. It'll show you an amortization table. And we looked at this in class also. It shows you a pretty nice one because it keeps track of the total interest. So we can scroll all the way down, and 171 grand is the total interest, which is the number we already knew. We already calculated that. Sorry, this takes a while to scroll through. Okay, so you can also, when you have a table like this laid out, you can just scroll through it and figure out what the remaining balance is at certain times. So if you care about what the remaining balance is after 1 year, well, 1 year is 12 payments, so I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's my 12th payment. The remaining balance after that 12th payment is 172,509. Okay, so you can just scroll through this thing and find the remaining balance at whatever time you feel like. And for certain questions on your exam and for certain questions on your homework, you'll be able to do that. The last reason I like this is because a lot of people don't just make the minimum monthly payment. A lot of people do, well, they do different things. So for example, suppose you don't want to pay $960, you want to supplement that. So you decide, well, I can afford an extra $60 a month for this. Okay, it will show you a table for that. And so notice $960 was the original payment. The payment amount now is $1,020 because they added 60 to that. And so let's see. Then you can scroll down to the bottom and see how much interest you saved. So before we paid 171 grand in interest. Now we're paying 146 grand in interest. Okay. So you saved, what is that, like 25 grand in interest by doing this. And it also gives you a sense of how much earlier you'll pay it off. So let's see, this was a 30-year loan. So it starts in 2014. So if you're going to go off 30 years, that means you wouldn't finish paying it off until 2044. But look, the last row of this table is 2040, not 2044. So it's cutting approximately 3 years off your loan by doing this. So this calculator is fun to play with, so you can get a sense of your loan, how it will go, and you can tweak things like this. So some people don't do an extra amount every month. Some people wait till the end of the year after they get a bonus or something, and they'll pay an extra $600 every December, say, at the end of the year. So I can get a table for that. It tells me I'm going to pay it off in 2041. So $600 at the end of the year doesn't get it done as early as $60 every month. But again, I can figure out the total interest, 149 grand. So this time I only saved about 21 grand rather than 25 grand. So in any case, when you get a loan of your own, you should sit down and play with a calculator like this and get a sense of what's going on. And you will have questions like that in your homework that explicitly say, use the bankrate.com calculator. And this is what you can use. So I will send you the link to this calculator for you to use in your homework. And that's the end of this lesson.